Hello everyone, and welcome back. Today we are going to discuss an important topic in substructure construction called Caisson foundations. Caissons are widely used in bridge engineering and marine structures, where ordinary shallow foundations cannot provide adequate support. By the end of this lecture, you will understand what a caisson is, its types, components, construction methods, and the challenges encountered during sinking operations. The word caisson is derived from the French word caisse, which means a box. A caisson is a large, hollow, deep foundation that is constructed on land or water and then sunk to the required depth. Once placed, it becomes a permanent part of the substructure. Caissons are commonly used for the foundations of bridges, piers, abutments, docks, harbors, and offshore structures, especially where construction takes place in rivers, lakes, or seas. The main purpose of a caisson is to safely transfer heavy structural loads to stronger soil or rock layers located deep below the ground surface. Caissons are generally constructed using reinforced cement concrete, steel, timber, or cast iron. Based on their construction, they are classified into three types. 1. Box caisson. 2. Open or well caisson. 3. Pneumatic caisson. Each type is selected depending on the depth of the foundation, soil conditions, and construction requirements. Let us discuss each type individually. A box caisson is open at the top and closed at the bottom. It is usually constructed on land, floated to the construction site, and then lowered onto a prepared foundation bed. Before placing the caisson, the riverbed is leveled by dredging to create a stable bearing surface. The caisson is then sunk by filling it with sand, gravel, or concrete. Box caissons are suitable when the bearing stratum is available at shallow depth. Structural loads are relatively light. The main advantage is that the construction cost is low. However, there are some disadvantages. The foundation bed must be prepared before placing the caisson. It is not suitable for greater depths. Protection against scour around the foundation is difficult. This image illustrates an ongoing construction project involving a large caisson structure. Here we see a caisson being transported to its final location. The open caisson, also called a well foundation, is the most commonly used type in bridge construction. Unlike the box caisson, it is open at both the top and bottom. Excavation is carried out from inside the well, causing the caisson to sink gradually under its own weight. It is preferred when excavation depths exceed 5 to 7 meters, making open excavation uneconomical. Since the well remains permanently as part of the structure, it serves both as the construction aid and the final foundation. An open caisson consists of several important components: cutting edge, well curb, steining, bottom plug, top plug, well cap, sand filling. Each component has a specific function in ensuring safe sinking and load transfer. The cutting edge is a sharp steel edge that cuts through the soil during sinking. The well curb, usually made of reinforced concrete, supports the cutting edge and guides the sinking process. The steining forms the main body of the well and is generally made of RCC or masonry. After reaching the desired depth, a bottom plug made of concrete is placed to seal the base. The hollow portion is then filled with sand, which helps distribute the load. Finally, the top plug and well cap are constructed to transfer loads from the bridge pier to the foundation. The sinking process is carried out by excavating soil from inside the well. As the caisson sinks deeper, friction develops between the surrounding soil and the outer surface of the well. This friction is known as skin friction. To overcome this resistance, additional weight called kentlage is placed on the top of the well. Sometimes water is pumped out to improve sinking efficiency, but excessive dewatering is avoided during the initial stages to prevent instability. The advantages of open caisson are: it can be constructed to much greater depths. It is relatively economical for bridge foundations. Its disadvantages include: the bottom cannot be inspected directly after sinking. Progress becomes slow if boulders or hard rock layers are encountered. Now let us discuss the pneumatic caisson. This type is closed at the top and contains a working chamber at the bottom, where excavation is carried out under compressed air pressure. The compressed air prevents water from entering the working chamber, allowing workers to excavate safely even below the water table. 2 airlocks are provided, one for workers, another for removing excavated soil. Although pneumatic caissons are very effective for deep underwater construction, they are more expensive and require specialized equipment. This diagram shows the various internal components of a pneumatic caisson, including the working chamber, air shafts, and airlocks used for access and excavation. One important health hazard associated with pneumatic caissons is caisson sickness, also known as decompression sickness. When workers leave the compressed air chamber too quickly, dissolved gases in the blood form bubbles, causing health problems. Common symptoms include dizziness, headache, double vision, difficulty in speaking, pain in joints and muscles. To prevent this condition of caisson sickness, limit workers to 1 shift per day. Keep shifts within 12 hours. Maintain a working temperature of around 25 degrees Celsius. Ensure proper ventilation. Provide medical facilities and adequate nutrition. Avoid alcohol consumption. This table compares the two types. Open caissons are simpler and economical but unsuitable, where water inflow is excessive. Pneumatic caissons are suitable for deep underwater foundations and allow better control during excavation, although they involve higher construction costs and health risks. Several methods are used to assist sinking: air and water jetting, blasting, loading using Kentledge, sand island or artificial island method. The choice depends on soil conditions and project requirements. Now that we have understood how a caisson is sunk into the ground, let's look at an important practical aspect: the challenges encountered during the sinking process. Although the construction procedure may appear straightforward, several field problems can arise due to varying soil conditions and groundwater. The three most common challenges are sand blowing, tilting of wells, shifting of wells. If these problems are not identified and corrected early, they can delay construction and even affect the stability of the entire bridge foundation. Let's understand each of these challenges one by one. Sand blowing usually occurs when a caisson sinks through loose, sandy soil. During sinking, engineers may remove water from inside the well to ease excavation. However, dewatering in sandy strata creates higher groundwater pressure outside the caisson, causing surrounding sand to rush inward. This is similar to a vacuum drawing in loose sand, leading to ground cracks and collapse around the well. In severe cases, sand may suddenly fall into the caisson to depths of 3 to 15 meters, making the operation hazardous. To prevent sand blowing, dewatering should be stopped immediately. Engineers then place bundles of grass, straw, or similar materials around the outside of the well steining to stabilize the soil and safely continue the sinking process. The next challenge is tilting of the well. Ideally, a caisson should sink vertically so the bridge pier remains at its designed location. However, if one side sinks faster than the other, the well becomes inclined, resulting in tilting. This usually occurs due to unequal dredging, or more soil is removed from one side, or non-uniform soil conditions, or one side rests on softer soil than the other. To correct tilting, engineers may apply eccentric loading by placing additional weight on the higher side to promote uniform sinking. Other corrective measures include water jetting, pulling the well with cables, and pushing it using hydraulic jacks. Continuous monitoring during sinking is essential, as small tilts are much easier to correct than large ones. The final challenge is shifting of the well, which is the horizontal movement of the entire caisson away from its intended position. Unlike tilting, where the well leans, shifting occurs when a tilt is left uncorrected during sinking. As sinking continues, the base gradually moves sideways, causing the horizontal displacement at the bottom to become much greater than at the top. Even a small shift can misalign bridge piers and increase structural stresses. To prevent this, engineers continuously monitor the well's verticality and position throughout the sinking process. If any deviation is detected, corrective measures are taken immediately, ensuring the caisson reaches its design location accurately and safely. To conclude, caissons are one of the most reliable deep foundation systems used in bridge and marine construction. We discussed the three types of caissons: the components and sinking process of well foundations, the working principle of pneumatic caissons, caisson sickness, and the common construction challenges. Understanding these concepts is essential for designing safe and durable foundations for structures built in difficult ground and underwater conditions. Thank you.